Hello, so today we are talking about probability. The question that I chose out of the three questions was question 3, so that's what we'll be covering in this video. So looking at the first question, question 3a, a box contains 7 cards numbered 1 to 7. 2 cards are drawn at random without replacement. Find the probability that the numbers on the 2 cards drawn out of the box give an odd product. Now, looking at the equation that I did, 4 over 7 times 3 over 6, which gives you 2 over 7. That's the answer. But that obviously doesn't help. You have to look at how we figure this out. So I drew a tree diagram over here. And by looking at the tree diagram, you can see that we need to look for the 2 odds, because 2 odds obviously equal an odd, and that's the only one, and that's what we're looking for. The product of the 2 odds. So 4 over 7 times 3 over 6, which is what I wrote here, because it's an odd and an odd. But you'll notice that the denominator has grown smaller in the second one. That's because the pool gets smaller in the second time because it's without replacement, as said in the question that I read. The combination to find is obviously, as I said, 2 odds, so that's what we're looking for. Now, you have to times along the branch, as I mentioned, and then this is just more of a side note. If you're using multiple branches, then you'd add them. So, for example, if you wanted to know the probability of odd times an odd, as well as even times an even, then you go 4 over 7 times 3 over 6 plus 3 over 7 times, I think that's also 3 over 6. No, sorry, that's 2 over 6. But yeah, so that covers the first question, question 3a. Now, taking a look at question B2, which reads, find PA and not B. Now, in order to find this, I did my workings out over here, and you'll see that I wrote PA and not B is equal to 0.55 minus 0.25, which will give me 0.3. Now, looking at the Venn diagram, how I work that out, you go, it's PA and not B, and so the 0.55 comes from the whole of A, so 0.3 plus 0.25 minus 0.25, which is the middle section that we originally added to the A on its own, because it is in the circle of B and it said not B. So that for that reason we have to take it away from the 0.55. Now, taking a look at question 3b. For 2 events A and B in the sample space S, it is given that PA is equal to 0.55, PB is equal to 0.6, and PA and B is equal to 0.25. Now, looking at B1, draw the Venn diagram to represent the information. So, as you can see, that's what I've done right here. I drew the Venn diagram. Now, drawing this, it is important to make sure that when dealing with Venn diagrams with probability, to ensure that it all equals to 1, because it obviously only told us the stuff that's within the 2 circles, but it didn't make mention to the little 0.1 on the outside. Also, you also need to make sure that you minus the A and B, which is 0.25, from the given 0.6 and 0.55, shown 0.6 that was supposed to be there, and 0.55, which was supposed to be there, for A and B. Now, taking a look at B3, you'll see that B3 is P, A, or not B. Now, you may get confused between the two, but there is quite a drastic difference. You'll see that I wrote equals 0.3 plus 0.25 plus 0.1, which gets me 0.65. Now, how I worked that out, again, looking back at the Venn diagram, I went 0.3, which is A on its own, without anything to do with B, plus 0.25, which is the middle section, since it's the whole of A, because it says A, so it's 0.3 plus 0.25, getting you the whole of A, plus 0.1, because there's this little 0.1 that you may have forgotten about originally. Because it says A or not B, and anything that is not B is A and the external 1. Now, I personally got a bit confused when doing this because I was thinking, well, surely 0.25 is still a part of B, therefore that's a part of not B. So, but in this case, when looking at this, you do actually include the 0.25 as A, even if it is a part of B. Alright, so now we're on to question 3C. Now, that question reads, a group of friends decide to plan a trip to Europe with the intention of visiting Rome, Madrid, Florence, Milan, Geneva, and Paris. They choose the order of their visits randomly. C1, you'll see that I wrote 6 factorial. Now, factorial is the little exclamation mark that you'll find on your calculator. Now, if you put this into your calculator, you'll get the answer 720. Now you may not understand what factorial means, so I drew out this diagram over here just to elaborate and explain on what factorial means. So you've obviously got 6 available options, so I put 6 boxes, but each time you lose an option. So 6 options, 5 options, 4 options, 3 options, 2 options, 1 option. Now, with then what to do is that since it's all in a repetitive order, you then times them all together in order to get your, like, all your different probabilities. And so that's what factorial means in the greater scheme of things. Okay, question C2. It reads, if Rome, Madrid, and Florence are grouped together in that order, determine the number of different orders of their visits. Now, to work this out, I wrote 4 factorial, which, if you put into your calculator, will get you the answer 24. Now, you're probably wondering, what the hell, this is so confusing, how am I supposed to work this out? But it's rather simple. By just putting it into a diagram, I can easily explain it to you. So you'll see that it's asking for Rome, Madrid, and Florence to all be together in every single probability, or possibility, sorry. So then if you just repeat the exact same diagram I drew for C1, except in this case, you're going to group Rome, Madrid, and Florence all together. So you'll see I put the little lines just to connect them. But so that all becomes one big unit. And so with that unit, you go 4, 3, 2, 1 instead of 6, 5, 4, 3, 2, 1. And so then you only have to times 4 units together instead of 6, and that's how you work out this question. Alright, now we're on to our third and final question for C. It reads, what is the probability that they will visit Rome, Madrid, and Florence, one after one another, in any order? give your answer correct to 1 decimal place. Now, to work this out, you'll look here and you'll see that I wrote in my equation 4 factorial times 3 factorial over 6 factorial. And the reason why I did this is because going back to the previous question, C2, I'm sure I made it 4 units instead of the original 6 because of that grouping. Now we're continuing that here because, again, it's making mention to the fact that Rome, Madrid, and Florence are all together. So then it becomes the 4 units again. But this is where the difference is. I have to times that by 3 factorial because we also have to work out the probability that it will lie in the order of Rome, Madrid, and Florence within that unit that I shrunk down. So that's where the 4 factorial times 3 factorial comes from. Now, you'll see that I divided it by 6 factorial. That's because 6 factorial is quite simply the full total of all of the different units in the original equation before having to do any of these alterations. So then what you do is that you just put that into your calculator and you'll get 144 over 720. That is if you just do the conversions, not let the calculator do the full thing, because obviously you want to show a few steps. So this is just that over that, but it's just in like a whole form. So, and then it's asking for your answer to be in decimal place. So it's asking for the decimal. Therefore, you just put 0.2. Because I'm sure that some people might make the simple error of leaving their answer as 1 over 5 instead of converting it over to 0.2 instead. Thank you for listening, and I hope you learned a bit more about probability. I know I did in this process.